Hello. In this video, I'm going to step through the solution of problem set 40, number 1, in the Saxon Advanced Math course, first edition. The problem is given in the description of this video, so we can just start by pulling things out from the problem. If you haven't read the problem yet, pause the video and read the problem, and then continue. The first thing that we find out is that the average speed was 40 kilometers per hour. We find out that the wheel's radius is 14 inches. And right away something should stand out to you. 40 kilometers per hour. This is the metric system. And wheel's radius is 14 inches. This is the English system. So there's going to have to be some changing from English to metric or vice versa, but let's see what the problem is asking for. The problem is asking for average angular velocity in radians per second. So we can either go with our inches from English to metric or metric to English. I have chosen to go into the metric system because being based on base 10, it's so nice to work with. But in either case, those units are going to cancel out because remember, radians does not have a unit that goes with it. Also remember that in the equation, v, I'll do like that, angular velocity equals the radius times omega. Omega is given in radians per second. It's given in radians per time. So all we really need to do to solve this problem is first solve for omega, which we can do by dividing both sides by r. Omega equals the angular velocity divided by the radius, and then making the units into the same system, and the answer should just fall out. So what do we have to plug in? We have, we're given that this is 40 kilometers per hour, and I'll write it like that instead of kph so we can keep it straight. And then we're dividing that by times, since we're dividing, I'm just going to put a 1 up there and our 14 inches in the bottom. So the first thing I want to do is change those inches to centimeters. And I'm going to have 1 inch is equal to 2.54 centimeters, and inches goes away. Then I want to get rid of these kilometers, so I can either get kilometers down to centimeters. Let me see what I did. Okay. So I'm going to put 1 kilometer down here to start getting rid of that, and that's equal to 1,000 meters. That's the meaning of kilo. Kilo means 1,000, so 1 kilometer has 1,000 meters. So notice in each case, 1 inch is equal to 2.54 centimeters. In each case now, I have started multiplying by a factor that's equal to 1. So I'm not changing anything but the form of the variables. But we don't really want meters, we want centimeters, so we put down here 1 meter so we can cross it off from there, and 1 meter is 100 centimeters. So far what we have done is we have, let's see, this kilometer cancels out that kilometer. Remember that units work just like numbers when they're in fractions, so you've got 1 in the numerator, 1 in the denominator, cancels out. We have this meter cancels out with this meter, And lo and behold, we have this centimeter in the bottom that cancels out with that centimeter. We also have these inches that cancel out with that inch. And so far, our answer is 40. And what else is in the numerator? 1,000 and 100. And we're dividing that all by 1 times 14 times 2.54, but we still have this hour down here. And the problem asks us to calculate omega in radians per second. What we have now is an expression for radians per hour. We want radians per second. So we multiply by 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. Oops, I just wrote the seconds. Let me just cross that out. I don't have an eraser for a Sharpie. And here's what's happening. The hour goes away because you've got 1 in the denominator and 1 in the numerator. The minute goes away because you have 1 in the denominator and 1 in the numerator, and all you're left with is seconds. And so, if you just rewrite your answer nicely, you have solved this problem. In this case, the angular velocity is equal to 40 times 1,000 times 100 divided by 14 times 2.54 centimeters per inch times 60 times 60. And you can put in radians per second because you have no other unit but seconds, because this is given in radians. When you use it in this equation, you're calculating radians, or you need it to be in radians for this equation to work. And that is how you would solve Saxon Advanced Math First Edition Problem Set 40, the first one.